All right, welcome to section 4.4. We're going to talk about the Pythagorean theorem and the distance formula. So before we talk about Pythagorean theorem, let's talk about the parts of a right triangle. The legs are the two perpendicular sides of the triangle. So these are the two sides, BC and CA, that make up the right angle. So here's the leg, and here's the other leg. Then we have the hypotenuse, which is across from the 90-degree angle. And sometimes I'll abbreviate that as HYP. So the side opposite or across from the 90-degree angle, the right angle, is called the hypotenuse. So here we had our two legs, and then we have the hypotenuse. So what does the Pythagorean theorem says? It says that the sum of the squares of the length of the legs of a right triangle is equal to the square of the length of the hypotenuse. So what that's saying is that a squared plus b squared equals c squared. Well, what is a? A is a leg. Leg squared plus leg squared equals hypotenuse squared. Now, for the purposes of this chapter, I am always going to write the problems as c squared equals a squared plus b squared, right? Because it doesn't matter what side of an equal sign you put something on because they're equal. So 1 plus 1 equals 2, and 2 equals 1 plus 1. Doesn't matter what order you say it in. But this will help you later on in the chapter if we just get comfortable putting c first. So c is the hypotenuse. So hypotenuse squared equals leg squared plus leg squared. Now we can only use the Pythagorean theorem for right triangles. So that's important. So find the length of the hypotenuse. So hypotenuse is across from the 90-degree angle. So hypotenuse squared equals leg squared plus leg squared. Okay. 5 and 12 are my two leg lengths. So c squared equals 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, which is 144. And we add those together to get 169. And now we want to get c by itself, so we have to undo the squared by doing the inverse operation, which is taking the square root. If you do something to one side, you have to keep your equation balanced and do it to the other side. And the square root of 169 is 13. Now, if you don't know how to find the square root of 116, I'll show you where it is on your calculator. So on your calculator, you're going to hit second and then this x squared key because that's going to give you the square root. And then type in 169 and we get 13. So again, hypotenuse is across from the 90-degree angle. So hypotenuse squared equals leg squared plus leg squared. Okay, 1 times 1 is 1, 2 times 2 is 4. Add 1 plus 4 to get 5. Square root both sides, and x equals, and we're going to give decimal answer, so let's type in the square root of 5 to get 2.24. We'll round to the nearest hundredth, so 2.24 for the length of our hypotenuse. Now, sometimes they give you the hypotenuse and they want you to find a leg. So again, hypotenuse is crossing the 90-degree angle. Hypotenuse squared equals leg squared plus leg squared. It doesn't matter whether you say b squared plus 7 squared or 7 squared plus b squared because it doesn't matter what order you add. So 14 squared is 196. B squared and 7 times 7 is 49. So we're going to subtract 49 from both sides, and that gives me 147 equals b squared. And then we want to get b by itself, so we're going to do the inverse operation to get rid of the squared by taking the square root of both sides. And when we type in the square root of 147, we get 12.12. do one more example. Oops, hang on. All right, so again, hypotenuse squared equals leg squared plus leg squared. My hypotenuse is 10 across from the 90-degree angle, so 10 squared equals a squared plus 6 squared. 10 times 10 is 100. 6 times 6 is 36. Next step is to subtract 36 from both sides. We can't take the square root yet. So we get 64 equals a squared. Now we can take the square root of both sides. And the square root of 64 is 8. So a equals 8. All right, the distance formula. If A has the coordinates x1, y1, and B has the coordinates x2, y2, then the distance between A and B is, here's the distance formula. So notice it says AB, that's the length. It's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You do have to memorize that for the test. So the distance from A to B equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So let's label our points. It doesn't matter which one you call x1, y1. We'll just call the first one x1, y1, and we'll call B x2, y2. So now let's plug these in. So x2 is 3. So I'm going to plug in a 3 here. Minus x1, which is 0. So minus 0. Plus quantity squared plus y2 is 4 minus y1, which is 0. So first, let's do what's inside the parentheses. 3 minus 0 is 3, so we have 3 squared, plus 4 minus 0 is 4, so 4 squared. Okay, now we're going to square each of them, so 3 times 3 is 9, plus 4 times 4 is 16. Let's add 9 plus 16 together to get 25, and the square root of 25 is 5. So the length of AB, or the distance, is 5. Okay, distance and length mean the same thing. Hardest part of distance formula is setting it up and getting your x1, x2, x1, y1, x2, y2 in the correct place. So here, we'll call this x1, y1, x2, y2. Okay, so the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So let's plug it in. x2 is 3 minus x1 is 1 quantity squared plus y2 is negative 2 minus y1 is 2 quantity squared. So now let's subtract what's inside the parentheses. 3 minus 1 is 2, so we have 2 squared, plus negative 2 minus 2 is negative 4 quantity squared. Notice that I put the negative in parentheses. If you type this in your calculator, it's going to tell you that it's negative 16. But if you type this in your calculator, it's going to tell you that it's positive 16. Anytime you square something, it's always going to be a positive number, because a positive times a positive is a positive, and a negative times a negative is a positive. So anytime you square something, you should always be getting a positive number. So 2 times 2 is 4, and negative 4 times negative 4 is positive 16. So 16 plus 4 gives us the square root of 20, and if we plug that in our calculators, we get 4.47. For the length of, this is D. I'll do one more. right, let's do this one because it has a lot of negatives. So the square root of, let's label our points first. So x1, y1, x2, y2. So the difference in the x's, quantity squared, plus the difference in the y's, quantity squared. So x2 is negative 2 minus x1, which is negative 3. And then the difference in the y's. y2 is 2 minus y1 is negative 3. Notice I'm subtracting a negative, so make sure that you don't drop any negatives there. So then this is the square root of negative 2 minus a negative turns into plus. So negative 2 plus 3. And 2 minus a negative 3 turns into 2 plus 3. So we have negative 2 plus 3, which is 1. So that's 1 squared. Plus 2 plus 3 is 5. So that's 5 squared. Okay, well 1 times 1 is 1. And 5 times 5 is 25. So 1 plus 25 is 26. And the square root of 26 is, oops, 5.10. So AB is 5.10.